find the value of x, the domain, which satisfy 5x minus 10 is greater than 4x minus 7. This is a linear inequalities. And to solve this, I need to say 5x minus 4x minus 10 plus 7 is greater than 0. So I've taken all the left-hand side, right-hand side, and move it to the left. So 5x minus 4x, I get x minus 3 greater than 0. And that implies x is greater than 3. The quadratic here, I could solve that by factorizing. I'm sure this can be factorized. There's a way to check if it can be factorized. Use the discriminant. D equals b squared minus 4ac. If that equals perfect squared, then it can be factorized. So I can say b squared, b is a equals 2, b equals minus 11, and c equals 5. So b squared is minus 11 squared minus 4 times 5 times 2 and times 5. And that would give 121 minus 40. 5 times 4 is 20. 20 times minus 2 is minus 40. And if I take away 40 from 121, I get 81. And 81 is 9 squared. And that's a perfect square. I can factorize it, or I can actually apply the formula, since I've already worked out the d. So x equals minus b plus or minus square root d over 2a. And that would give minus 11 plus or minus. Now, d is 81. Square root of 81 is 9 over 2a, that means 4. So I get 11 plus or minus 9 over 4. That's for x, and that gives x equals 11 plus 9 is 20 over 4, or 11 minus 9 is 2 over 4. Therefore, x equals 5 or half. So the roots are x equals 5, x equals a half. And that's what we need to use to answer the inequalities. Now, let's solve the inequalities now. I'm going to draw a line for my graph. And I draw the x-axis here. I can see the roots there are two roots. One is quadratic. The b part is quadratic and the a part is linear. X is greater than 3. So if this is 1, 2, 4, 5, 6. So that's the x-axis there. Minus 1. And if this is 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. Right. The intercept on the y-axis is plus 5. So the graph is going to cross at +5. One of the first root is x equals 5. So x equals 5 if that. And the second root is x equals a half. So this is a half. I could also find the turning point, x value at the turning point. At the turning point, x is minus b over 2a, which is minus 11 over 2 times 2, that's 4. That becomes 11 over 4. 11 over 4 is 2.75. Right, so 2.75 is my 11 over 4. So I'm going to draw the line here for the line of symmetry, which is the value at which value of x at the turning point. That's x equals 11 over 4, line of symmetry. Intercept on the y-axis here, the root and the other root. So the graph is coming down from the second quadrant. Do we have a turning point at x value somewhere here? And then we go through one of the roots at 5, and then we'll go up. Right. But the line x is greater than 3 is this line here, x at 3. So that's the linear x is greater than 3, x greater than 3. But the inequalities is saying that the function 2x squared minus 11x plus 5 is less than 0. Okay, if it's less than 0, it's below the line y equal to 0. This is x-axis. So if it's less than 0, which means that we'll be looking for it's greater than x for the linear, all this value here, and less than 0. So we're looking at 3 and 5. And that region of x. So the domain is curly bracket x colon. I'm starting from the lowest value, which is 3, is less than x, and it's less than 5. Close by curly bracket. So both inequalities are satisfied when 3 is less than x, less than 5.